It's a great honor of mine to welcome to the stage our next speaker, Dr. George Slavich, who is one of the world's leading stress researchers and directs the UCLA Stress Research Lab, and actually kicked off my own career here in academia. I searched UCLA for the coolest professors there, and George was #1 on the list. So fun fact about George as he comes up, he actually worked here at Stanford with Phil Zimbardo, who you all might know as the Stanford prison experiment. So you can ask him about that later. And he might have some very extraordinary news to share that might still be confidential. Okay, it's confidential, but it's not confidential. Okay, well, so we'll share more about that later. It's pretty extraordinary to progress the field of mental health and wellness. So yeah, without further ado, with one further ado, you're ready. Okay, great. All right, so big round of applause for George. And if you want to even stand up, and add some energy to this, it's a big deal for somebody to come up on stage and talk. It's very stressful. Thank you. All right, we got some energy now in the room. All right.
I apparently have not been a very good boy in 2023 to be scheduled after that amazing session, though. Thank you so much for opening us up and for that kind introduction, Ben, and for having me here today. I'd like to spend just 20 minutes and talk to you about some of the surprising science that is now telling us how social experiences, positive and negative, reach deep under the skin to impact the basic building blocks of human life and health. The reason I'm really interested in this is because as Americans, we currently suffer from more chronic disease-related mortality than our counterparts in 15 other economically comparable countries. In fact, the only economically comparable country that has more disease-related mortality than the US is Denmark. A similar story emerges if you look at life expectancy in the United States. We're not first or second or third or fifth even. We're last in life expectancy for males and second to last in females relative to our economically comparable counterparts. About 20 years ago, women were halfway down the list and now have dropped to second to the last. In fact, 9 out of 10 deaths in the US today are associated with the conditions that you see here: depression, Alzheimer's disease, breast cancer, ovarian cancer, obesity, diabetes, and heart disease. 75% of all healthcare spending is attributable to these chronic disease conditions. The current cost to the United States is more than $2 trillion per year. And what's most disturbing to me is that the majority of this disease burden is preventable. For example, we have the highest rates of infant mortality, highest rates of obesity in adolescence, and highest rates of cardiovascular disease in adulthood. As Trump always says, America first, right? But this is not in the right way. There are many factors that contribute to chronic disease risk, I'm sure that you're thinking of right now, including smoking, poor diet, sedentary lifestyles. But what's really stood out to me is that the #1 killer is not any of these usual suspects, as Dr. Mike Snyder already highlighted, but it's lurking in plain sight and killing us softly. That's stress. What you're seeing here is the top 10 leading causes of death in the US in the year 2017. And on the right side, the odds of dying associated with adverse childhood experiences. These are nasty things that occur before you turn 18, things like childhood abuse, neglect, maltreatment, having an incarcerated incarcerated mother or father. The odds associated with many of these causes of death are staggering. 2.1 for heart disease, 2.3 for cancer. Look at suicide attempts. 37.5, probably one of the most striking risk factors for suicides is adverse childhood experiences. How can it be that these effects, these social psychological experiences that happen to us during the course of development, during the course of adulthood, reach so deep inside the body to regulate the immune system and impact health? Well, what you're seeing here is a relatively simple schematic cartoon drawing of an immune cell. On the immune cell wall, you see all of these different receptors for cool things in the immune cell environment, things like bacterial products, so If you have bacteria introduced into the body, obviously your immune cell needs to respond, so it has receptors for that. Other inflammatory cytokines are key mediators of the immune response that Mike already alluded to. Of course, immune cells have receptors for other cytokines. But also, guess what? Immune cells are rich in receptors for the two end products of two stress axes, the hypothalamic pituitary adrenal axis. So we have rich receptors for cortisol and rich receptors for norepinephrine. What happens inside the cell? Normally, you have these two transcription factors, inhibitor of kappa B and NF-kappa B, that are holding hands in the cytoplasm of the cell. But once you have a stress signal, like cortisol or norepinephrine, it causes inhibitor of kappa B to break down, allowing NF-kappa B to translocate into the nucleus of the cell and to induce pro-inflammatory gene expression. The immune cell then produces these pro-inflammatory cytokines that get sent all throughout the body. And if you've ever had a cut on your arm, you may notice a little bit of redness, swelling. That's inflammatory cytokines being recruited to the site of that injury to accelerate wound healing recovery. But guess what? Cytokines can also communicate with neurons in the brain to induce a hypersensitive, threat-sensitive, hypervigilant state. They can also make you tired, fatigued, change your entire biobehavioral state, and over time cause oxidative stress and accelerated biological aging. One of the most fascinating features of this dynamic is that the immune system doesn't just wait for danger to occur in order to mobilize. The immune system, rather, is an anticipatory system that relies on the brain to continually survey the external social environment to identify whether the person is in a relatively friendly environment or relatively dangerous environment. Why would that have been evolutionarily adaptive over the course of time? Because if I'm in a conversation and I assess the situation as being relatively friendly, then my risk for physical wounding to the body is relatively low. If now that conversation goes south and now I'm engaged in a conflictual conversation, the risk for wounding increases. So what would have been an adaptive response over the course of evolution is to mount this inflammatory response to the first indication of potential social environmental threat in the environment so that immune cells get sent to all compartments of the body, and if my body is wounded, those immune cells are already there and can accelerate wound healing recovery as fast as possible. And what happened to the people over the course of evolution who didn't have that response? They're not here anymore. Okay, we've tried to understand how it is that these experiences of the social environment get under the skin in a lot of different ways, and I'll tell you a few key ways in which we study this in the laboratory. This is a setup called the Trier Social Stress Test, a study of 124 adolescents from the UCLA community. We bring them into the lab and we surprise them. We tell them that, by the way, you're part of a study here. You're going to give a speech for 5 minutes about why you'd be a great job candidate. So we take a sample, which I'll show you in a second, before we tell them that, and then some samples afterward. So you come in, you have 5 minutes to prepare a speech on why you'd be a great job candidate, and then 5 minutes to give the speech. You stand up in front of this panel of raters, all wearing white lab coats, taking notes. We videotape and audio tape you. By the way, we tell you that we're going to send those videos to a communications expert on campus who can tell, based on your 5 minutes speech, whether or not you're likely to get a job, how much you're going to make, et cetera, et cetera. Maybe some of you like public speaking. After this 5-minute public speaking task, we do a mental arithmetic task. We ask you to start at 2,953 and count backwards by sevens out loud. Some people are really good at sevens, not me. We ask you to count backwards by 13s out loud. Every time you make a mistake, we ask you to start at the top. The experimenter, of course, is looking at their Apple Fitbit watch, Sensomix watch, et cetera, wondering why it's taking you so long. Okay, so how do we look at how the immune system responds to this very short 10-minute stressor? We use these OraSure collection devices, which are really cool. You have a substance in your mouth that is saliva. You all know that. You have another substance in your mouth that is called oral mucosal transudate, or OMT for short. It's a filtrate of blood, and guess what? It's rich in inflammatory cytokines. So we can use these OraSure devices, place it between the cheek and the gum line, keep it there for 2 minutes, and then send it off to the lab for processing. Gives a beautiful, non-invasive, enables continuous assessment of inflammatory cytokines. Two of the cytokines we focus on here are tumor necrosis factor alpha and interleukin-6. We take that sample when they come into the lab and they're relaxed before they know anything's going to happen. Then, of course, we tell them they're going to do the speech task, the math task, and we take samples afterward as well. Okay, so what happens in the body in response to this really short 10-minute social evaluation stressor? On the panel on the left, you're seeing tumor necrosis factor alpha, key inflammatory cytokine. The panel on the right, interleukin-6. The stressor is only 10 minutes. So I just want you to think for a moment how many times in the past week you've been stressed out for 10 minutes, right? Mounting an enormous inflammatory response throughout the body, in this case in the mouth, we're measuring it, and huge increases in tumor necrosis factor alpha and interleukin-6. Now, I didn't show you the individual differences there, but as we've already heard, there are huge individual differences in the extent to which I'm going to mount an inflammatory response compared to you. And how can we understand who is socially sensitive to social evaluation versus who isn't? And then how can we use that mechanistic information for therapeutic purposes? Well, in this particular follow-up study, what we did is we brought those people back into the lab, into the Staglin One Mind Center for Cognitive Neuroscience at UCLA, and we scanned their brains while they were socially evaluated. So where in the brain should we look to try to understand differences in inflammatory responding to social stress? Well, we know that inflammatory responses are a key response to physical pain. So we looked in the brain to sites in the brain that are responding to physical pain to understand whether or not those same sites may be guiding inflammatory responses to social stress. Two sites of the brain, dorsal anterior cingulate cortex, DACC for short, and anterior insula. So what happens when you're in this study? You come into the lab and you meet two other totally randomly named individuals, in this case, Ben and Ariel, and they seem very nice, they're smiling, they just, invited you all here. You go into the fMRI scanner and you have a button box in your dominant arm. So now Ariel and Ben are in other rooms, and presumably what you think is happening is that every time Ben passes the ball to you, you get to push on the button box. Do you want to send it back to her, or do you want to send it to Ben? Right? So you're sitting in the fMRI scanner, you have the button box. Every time you get the ball, you get to pass it to either of the two of them. What we don't tell you is that randomly, halfway through, without any explanation, Ben and Ariel decide that they're going to play on their own, leading to an experience of social exclusion while you're on the fMRI scanner. So what we can do is examine neural responsivity to the condition where you're socially included minus the condition where you're socially excluded, and get a very simple metric of the extent to which the brain is socially sensitive to social exclusion. And what happens? Two key findings. First of all, the primary sites of activation in response to social rejection are the exact same sites in the brain that respond to physical pain. Neurobiological overlap between the neural representation of social pain and physical pain. And the second thing is that now we have a very sensitive neurobiological marker of differences in inflammatory reactivity to social stress. These brain sites very strongly predict the extent to which individuals mount an inflammatory response in the daily environment. So that may sound really dire, right? Because now I'm saying, well, the more socially sensitive you are to rejection, the greater inflammatory response you're going to have during the course of life. But guess what? It cuts both ways. So in this data, which is really hard to see on your slide, we show that individuals who enter that experiment with a stress is enhancing mindset show less depression, less fatigue, and less inflammatory responses to acute social evaluation than the individuals who believe that stress is an opportunity to fail. So what does stress is enhancing means? It means you're going to go in it. This stressor is an opportunity to do your best, right? To practice what you've learned, to practice your coping skills. If you have that mindset, you have a completely different physiological and biobehavioral response than if you enter that same situation and you believe that this situation is an opportunity to fail. Okay, let me give you one other example, and then we'll switch gears here. We try to replicate all of our studies. So again, another study we did in the Staglin Center at UCLA. We brought participants into the lab. In the first session, we interviewed them about their goals, plans, and aspirations for the future, their upbringing, their personality. Then they came in for a second session, and they were introduced to another individual who they thought was actually part of the study, but is a Confederate, part of our study staff. And we flip a coin, ostensibly, and the participant always goes into the scanner. And what we tell the participant is that you're going to go into the scanner, and the person outside is going to watch your interview, 10-minute interview, and judge how you're coming across in that interview. Okay, so on the left-hand side here, you see the Confederate. She's ostensibly watching the interview we conducted with you. On the right-hand side, you're going to the fMRI scanner. What do you see in the fMRI scanner? You put on fMRI-safe goggles, and you see a matrix of words. And what you think is happening is that the other person is judging how you're coming across in the interview that we conducted with you. Okay, so now they think you're interesting. So you said something probably that was interesting to them, but of course the other shoe drops, and now they think that you are, what do you think? Insecure. Okay, what's interesting about this paradigm is that it's actually not negative. 1/3 of the words are positive, 1/3 are negative, and 1/3 are neutral. So on balance, it's a balanced social evaluative experience, although most people don't find it that way. This is only a 10-minute video that I recorded on PowerPoint. So everybody sees exactly the same video. The Confederate's already gone home, right? They're not part of the study, really. The person is just watching a video. It's a 10-minute stressor. Systemic inflammatory levels skyrocket in a 10-minute stressor. Interleukin-1 beta, interleukin-6, tumor necrosis factor all go up. And what happens in the brain? Same exact associations. The more neurally sensitive you are, or less neurally sensitive you are, to social evaluation strongly predicts your inflammatory response to social rejection. I don't have a lot of time to go into these data, so we can talk about them later on, but what I want to say is that we now have this emerging field of human social genomics, where we can look at the basic inflammatory gene expression inside immune cells. And what we see is huge shifts, huge increases in pro-inflammatory gene response, huge downregulation of antiviral immune gene expression associated with people who experience themselves as socially disconnected, socially excluded, and socially isolated. And as I said, it's not a negative story, right? These are also therapeutic targets, social psychological therapeutic targets. So in this study with 53 low SES individuals from low SES backgrounds, Edith Chen and Greg Miller from Northwestern looked at the moderating impact of maternal warmth on low SES. And what do you find is that simply having high maternal warmth can buffer your pro-inflammatory gene expression that is typically associated with low SES. We see this, and this is all regulated by upstream stress pathways, in this case NF-kappa B and Krebs family factors. So greater experiences of social rejection, evaluation, marginalization, exclusion leads to greater pro-inflammatory gene expression and reduced antiviral gene expression. Maternal warmth and a number of other factors do the exact opposite. And we now have probably 10 to 12 randomized clinical trials showing that you can actually intervene and showing causal effects on a number of different gene expression profiles. And this holds for a lot of different therapeutic techniques: cognitive behavioral therapy, meditation, mindfulness-based stress reduction, and several others. This work, we think, really begins to provide an A to Z picture of how it is that social environmental experiences, both positive and negative, get represented by the brain, how the brain then regulates peripheral biological systems, HPA axis, vagus nerve, sympathetic nervous system, meningeal lymphatic vessels, that innervate all organs and systems in the body. The meningeal lymphatic vessel system is one of the most interesting. We now know that there's a cytokine superhighway, a physical structure that connects the brain and the peripheral body. So you no longer have to talk about indirect effects of the brain on the body via the HPA axis or the sympathetic nervous system. We now know that there's a physical structure that links the brain and the body that any kind of neuroinflammation that occurs can traffic to the rest of the body and impact all organs. Okay, I'm probably 100 minutes over, so let me wrap up here. This work requires a village, and so that's what we're going to build. In Mill Valley, it's the first time we're announcing it. Thanks, Ben, for teeing that off. A new scientific village, the world's first institute devoted specifically to stress and resilience, about 45 minutes north of here in San Francisco. So here we are in Mill Valley looking back at Salesforce Tower and Sausalito and everything south of us. So what's going to happen? We have a welcome center. We have an integrative health clinic, 40 faculty offices, 27 classrooms, an arts and events center so we can hold these events and similar events, and a culinary nutrition center, all as a institutionalized focus on mental health care innovation that we're talking about here. So maybe one time, in the near future, we'll be able to have a similar talk like this here. Culinary Arts Center, which will glue people together and also provide nutritional and dietary training, right? The basic building blocks, as Ariel knows better than anybody, is metabolic, nutritional, and metabolic health. How can we start with the basic building blocks? We're going to have up to a community of 600 housing units on campus, faculty, staff, student housing, all devoted to this one goal, which is mental and physical health care innovation. Beautiful spaces, and just to tell you what the Cells to Society pitch is here, we don't have basic biomarkers for toxic stress. If I lost my father earlier this year, all my healthcare providers knew about it. Nobody assessed my stress levels on an interview basis or on a biometric basis. I mean, and I have UC Healthcare, right? If you don't assess it, you can't address it. How can somebody give me a stress management technique if they're not assessing my stress levels? I mean, we need better continuous measurement, better biomarker assessment, et cetera. We then need to take those into randomized clinical trials, see which biosignals help with case conceptualization and treatment planning. We then need to take those into the clinic. We need to ask patients and providers what's helpful, what's not helpful, put it back into the research enterprise, put it back into the clinic, and hopefully it looks better than it did 5 minutes earlier. All that needs to be underpinned with health equity and social impact. As you know, most of the multiomics and genomics work is done only on advantaged populations, and that needs to change. Okay, all the papers I discussed are available on the website. Thank you all for your time, and namaste.
I'm sure there's a circadian effect to all of this inflammation and such. Have you looked at any of that as well? Like there must be some times that are better for handling stress than others, and especially in the particular circumstances you described.
Yeah, so question is, do you see circadian rhythm effects? So as you may know, the HPA axis is strongly regulated by diurnal rhythms. So is the immune system. And of course, those two are linked. So we haven't looked yet, for example, whether or not there are better times during the day to experience stress or not. But we do know that early adversity leads to a lot of cortisol flattening throughout the day, which has a huge impact on immune system regulation. So, and there are different assays that we can do that, dexamethasone suppression tests, different ways to identify the extent to which you basically have close, highly calibrated control of the immune system. And individuals who have sleep disruption, for example, have very poor control, HPA axis control of their immune system. So it's not just diurnal rhythms, but it's also the extent to which sleep disruption and high quality sleep impacts your diurnal rhythm, which is also really important.
Two questions. The Institute's very, very interesting. The first time I've seen this kind of living lab, so to speak, right, with this many people.
That's right.
Is there collaboration? Is this a UC project? Is it multi-university? What's the collaboration levels?
Yeah, so the collaboration levels will be all players that have a partnership that is strategically useful for the universities and for the institute.
Which university?
So UCLA, obviously, UCSF,
Yes.
Stanford, Berkeley will start working with partnerships with all of them.
And then the obvious question then is, how is this funded?
So we have a very generous in-kind donation from the family that owns the 130 acres. It's a $150 million in-kind donation to launch. And so we'll look for matching funds for that and then for programming funding as well.
Terrific. We'll see if we can help you with that. Great.
Thanks. George, good to see you again. How
Good to
have
see
you
you.
been? Great to see you. And congratulations on all this great success. Question about your finding on maternal warmth mediating the effects of stress and social rejection for low SES individuals.
That's right.
What kind of interventions do you envision to use that finding to actually make change in the well-being of individuals down the line who are living under those conditions?
Yeah, I was driving here this morning, and there was a great NPR special on, and I can't remember the name of it, but basically the first 3 years of life, of course, are critical for neurobiological development. And Ben is the father of a 2 or 3 year old. I'm the father of a 3-year-old. And you know what? Parenting is extremely hard. And nobody tells you the basic strategies to get your kid to sleep. Nobody tells you the importance of demonstrating personal warmth to your, I mean, for those of us who is obvious, it's obvious. For those of us who aren't psychologically minded like that, it's not obvious. How do you get your kid to sleep? How do you keep them asleep? Basic nutritional. So this program that was on NPR, which I think is a perfect example of what you're talking about, goes through these different modules, talks about maternal warmth, talks about sleep schedule, expected sleep schedule of a 2-year-old versus a 3-year-old versus a 4-year-old, talks about the importance of nutritional building blocks for mental and physical health. I think what we need, I mean, there's a lot of things we can focus on, but one of the things that I think is really easy to do is, not easy, easier, is to develop, to scale this kind of program to all maternal health care clinics worldwide. So what's the good thing about maternal and child well-being is that for the most part, they already have supportive services. So if you're connected with healthcare, as you know, so you have mom well visits, right, when the baby's in utero. After that, you have child well follow-ups. So part of the problem with these adjunctive psychosocial trainings is that you don't get to see the person often enough. But here what we can do is we have mom well visits before the child is born, child well visits after the baby is born. You have a period of about 2 to 3 years where they're already hopefully connected to healthcare. We can provide adjunctive trainings about child mental health, stress reduction, conflict management between the parents, et cetera. Because, I mean, it helps the parents, but it also disconnects this intergenerational transmission of stress and trauma from the mothers to the kids. And we know that, you know, in California alone, 62% of adults experienced a major adversity, and about 20% experienced 4 or more major adversities: sexual abuse, trauma, maltreatment, right? So we need to treat the parents, but we can also treat the kids by treating the parents.
Fantastic, thank you. One Mind has done some research in this area too and funded some new discoveries in the area, so we'd love to connect with you afterward to talk more.
Absolutely, thank you.
Great. Okay, we have one more burning question, very important. And by the way, I'm visiting on Friday if you guys want to come.
Come to Mill Valley. Yes, please.
Dr. Slavich, Dr. Diana Ramos, California Surgeon General, and I just want to thank you for describing how I, as an obstetrician gynecologist, am taking the ACEs work into the maternal child health arena. You described it so beautifully, and looking forward to our continued partnership, because we know that that is the way that we're going to be able to break the cycle and really improve the health not only of the mom, but the future generation. So thank you.
Awesome. Big round of applause. Thank you so much, George.
Great, thank you, everybody. Please come and introduce yourself. If you're excited about the location, please come and talk to me over lunch, over coffee. I would love to meet you. Thank you, Ben and Ariel. Thank you.
Great. Awesome.